Welcome back to the deep dive.
Yeah.
It is February 2026, and picture this: you open your laptop, you want to ask an AI to, I don't know, analyze your last 6 months of bank statements to find out where all your money is actually going, or maybe you want it to,
Sort through your inbox.
yeah, exactly, read through 1,000 unread emails and draft replies to the important ones. But before you drag and drop those files, you pause.
You definitely hesitate.
I hesitate because do I really want to upload my completely unredacted bank ledger to a server farm in, like, a data center I've never even seen? Do I want some massive corporation scanning my personal correspondence?
Right. And that is, I mean, that's the question of the year, isn't it? For the last few years, the answer was basically, well, look, if you want the magic, you have to pay the privacy tax.
Right. But today, we are doing something different. We're looking at a document. It's titled The Local AI Blueprint. And the premise here is pretty bold. It says, if you are still paying a monthly subscription to chat with an AI in the cloud, you are officially doing it wrong.
It sounds harsh, but the landscape has shifted that fast. I mean, this isn't just a white paper we're looking at today. It's a technical instruction manual.
Yeah, a literal blueprint.
Exactly. It claims we've hit this tipping point where you just don't need the cloud anymore. You can build a completely private agentic AI that runs entirely on your own hardware.
The overarching theme here is from renter to owner.
Yeah.
We've got the full stack of slides to walk through, literally page by page, to understand the why, the what, and the how. So let's just jump right in. Page 1.
Let's do it.
The visual here on page 1 is it's striking. On the left side of the page, you have this solid black featureless cube, just a box. On the right, you have what looks like this glowing, complex web of nodes.
Like a neural network.
Yeah, exactly, a neural network.
So this is visualizing the open source revolution. That black box on the left, that represents the proprietary models we've all been using for years. Think, GPT-4, Gemini, Claude.
Wow.
You put a prompt in, some magic happens inside that closed cube, and an answer spits out. But it is a closed system boundary. You have literally zero idea how it got to that answer.
And in the web on the right, the slide uses this term, black box dissolution, and then weight unpacking. That sounds heavy. Break that down for me. What are we actually unpacking here?
Okay, so at its core, an AI model is basically a digital brain made up of neurons. The weights, that's the technical term, they're simply the mathematical values that determine the strength of the connections between those neurons.
So kind of like the synapses in a human brain.
Exactly like that. In a closed model, the black cube, those connections are totally hidden. It's a tightly guarded trade secret. But in an open model, you get the file, you get the weights.
We can actually see the math.
Right, you can inspect the brain itself. So weight unpacking means the software isn't just some cloud service you visit. It's a file you actually own on your hard drive and can look inside of.
So it's the difference between, say, using a lockdown smartphone where you can't see the code,
right,
and having the actual schematics to build the phone yourself on your workbench.
Precisely. And that transparency, that is the foundation for everything else in this blueprint. I mean, you can't build a private, secure system if you can't even see inside the box.
Which leads us perfectly to page 2. This is a graph titled The Parity Event. And looking at this timeline, it circles January 2025 as the pivotal moment.
Yeah, this is arguably the most important chart in the entire deck. It tracks AI performance over time. If you look at the era before 2025, it's defined by the word dominance. You had companies that had what we call a performance mode.
Meaning their models were just factually smarter than anything else you could get your hands on.
Right. If you wanted the absolute best reasoning, you had to pay them. You had no other choice. But then January 2025 happens. The graph just spikes.
The release of DeepSeek R1.
DeepSeek R1, that was the earthquake. It was the moment the open source community and really the whole tech world realized, wait a minute, this open model, which I can literally download for free, is performing just as well as the proprietary model I'm paying $20 a month for.
The slide calls it commoditization. It says, performance is no longer a moat. High-fidelity weights are public.
And there's a quote there that really nails it. Open source AI is not a different species from closed source AI. That is the key realization. Once that performance gap vanished, the whole justification for renting a cloud brain just started to crumble.
Which brings us to the next section, renting versus owning. Page 3 contrasts the closed model with the open model.
It uses the analogy of renting an apartment versus building a house.
I like that analogy. Let's stick with it. So in the closed model, the renting side, what are the real downsides?
Well, first off, you have vendor lock-in. You're accessing the AI through an API. If that company decides to raise the rent like double the price per token tomorrow. You just have to pay it. If they change their privacy policy and decide, hey, we want to train our next model on your data, you're stuck. Or if they decide they just don't like the questions you're asking, they can cut your power.
Versus the open model, the slide emphasizes local execution.
Right. You download the weights, you run it on your own metal. It's your house. You can paint the walls whatever color you want. And crucially, and this is huge, even if the internet goes completely down, your AI still works. It's entirely self-contained.
Okay, but I have to play devil's advocate here for a second. Renting is really easy. I just log in and start typing. Building a house is hard work. You have to, maintain the plumbing. Page 4 gives us a cost-benefit analysis broken down into 4 quadrants.
It does, and it's a very fair assessment. Let's look at the advantages side first. The top left quadrant is the biggest selling point by far. Privacy and data sovereignty.
Zero data leakage.
Look, if you are in finance, healthcare, legal, or if you're just someone who deeply values their digital privacy, this is the absolute gold standard. The slide says air-gapped capable.
Meaning I could literally unplug my Ethernet cable, turn off my Wi-Fi.
You could sever your connection to the outside world, and the AI would still function perfectly. Literally zero data leaves the room.
That is just wild to think about. And then below that, there's cost and control. It says free inference and no token bills.
Because once you download the model, asking it a million questions costs the exact same as asking it one. It just costs whatever electricity your computer uses.
Okay, but here come the trade-offs. The top right quadrant, hardware intensity.
Yeah, that's the friction. High VRAM requirements.
Okay, pause on that. VRAM, that's video RAM, right, on the graphics card. Why does a text-based AI need video memory?
That's a great question. It's because these weights we talked about earlier, these massive files containing the neural network they need to be loaded into the fastest memory available to run efficiently. System RAM, like the normal RAM you have in your laptop, is usually just way too slow. The GPU memory, the VRAM, is the sweet spot for that kind of math.
So you can't just run these big brains on some old 5-year-old Chromebook.
Yeah. No, absolutely not. You need a modern machine, a Mac Studio with Apple Silicon, or a PC with a pretty beefy NVIDIA card. You are essentially trading a monthly subscription fee for an upfront hardware cost.
So the friction is the setup and the hardware.
Yeah.
And the freedom is the privacy and the control.
Exactly. And the blueprint argues that for a rapidly growing number of people, that trade-off is absolutely worth it, especially when you factor in the geopolitical shift that happened right alongside this.
Right, let's look at page 5, the geopolitical flip. This graph shows model downloads and usage. There are 2 lines here. Line A is U.S. models. Line B is Chinese models.
And look closely at where they cross. The flip happens right in July 2025.
That is honestly surprising. The red line, the Chinese models, completely overtakes the blue one.
Significantly overtakes it. The chart explicitly names the models driving this trend too. Moonshot Kimi, ZAI GLM, and Tencent Hunyuan.
And there is a staggering statistic on this slide attributed to Martin Casado from A16Z. It says 80% of startups are potentially using AI models made in China. Wow. I mean, why? Is it just that they are free?
It's not just price, it's optimization. While some of the big Western companies were purely focused on building these massive, closed moats in the cloud, these open weights were being optimized for local deployment.
Oh.
They made them smaller, they made them faster, and way more efficient to run on standard consumer hardware.
So while the giants were building, like, supercomputers, the open market was building engines that could actually fit inside a sedan.
Exactly. And the implication here is that innovation is truly global. We are impartial to where the code comes from, but the data shows Western markets are now responding with massive increased open source investment just to catch back up to that download volume.
So we know the models are good, we know they are free, and we know they are everywhere. Now let's really get into the how. Page 6 breaks down the open source stack.
This is the engine. It visualizes the 4 layers you need to have to run this locally.
Okay, let's walk through them. Layer 1 is the hardware.
That's your chassis, local GPU, Apple Silicon, Mac Studio. You need the raw iron.
Layer 2 is the model.
That's the fuel, the actual weights we talked about, your Llama 3, your Qwen, your DeepSeek.
Layer 3 is the manager, the API service layer.
Think of this as the transmission, and the blueprint specifically highlights Ollama here. This is the piece of software that actually makes the whole thing usable for normal people.
And finally, layer 4, orchestration. Tools like N8N, LangGraph, Python scripts.
That's the driver. That's what actually tells the car where to go and what to do.
I want to zoom in on that layer 3, the manager.
Yeah.
Page 7 is entirely about the model manager, Ollama. Because frankly, for a non-coder, hearing the phrase running a local server sounds terrifying.
It used to be. Before Ollama, running a model locally was just a total nightmare of Python dependencies and environment variables. You practically needed a computer science degree just to get the thing to say hello.
But the workflow shown here looks deceptively simple. Step 1, download software. Step 2, pull model. And the command is just literally Ollama pull llama 3.
And then step 3, serve API. It runs on localhost.11434.
Okay, localhost. Explain that concept for the non-technical listener.
Sure. So normally when you go to a website, you type in google.com and your computer reaches out across the internet to a physical server in California or wherever. Localhost means your computer is literally talking to itself.
Okay.
It creates a little private web server inside your own machine. So when you send a message, it travels 0 miles. It never leaves your chip.
And the takeaway for me here is just how incredibly clean that command line instruction is. 3 simple words to get an alien intelligence running on your laptop.
It really is. And the slide mentions LM Stats Arena as the go-to resource for choosing which model to pull. Because there are thousands of models now, and they update almost weekly, so you need a leaderboard to know what's actually good.
Okay, so we have the brain running. But a brain floating in a jar doesn't actually do anything. It just sits there answering questions. Page 8 introduces the anatomy of an agentic system.
This is a huge shift. This is where we move from chat to agents. It's the shift from talking to a philosopher to basically hiring a worker.
The center of the diagram is the LLM labeled the reasoning engine. But look at all these spokes coming off it.
Right. You have tools, things like calculators, web search, external APIs. You have memory vector stores, which we'll get into, and orchestration, the planning loop.
That planning loop.
Yeah.
Plan, execute, observe.
Yeah.
Walk me through that in practice. How is that different from me just opening a tab and asking a chatbot a question?
Okay, so if you ask a standard chatbot, hey, what is the weather in Seattle? It looks at its training data and says, I don't know, my training data cut off in 2023.
Right.
An agent is different. An agent says, I don't know the weather, but I have a tool in my toolbelt called web search. I will plan to use that tool. I will execute the search. I will observe the result. Oh, it is raining in Seattle. And then I will formulate a report back to you.
It totally transforms the AI from a static encyclopedia into a dynamic problem solver.
Exactly. It gives the AI hands.
Now, for the builders listening, page 9 offers 2 paths to implementation.
It's a fork in the road. On the left side, you have no code or low code. That's using Docker, Ollama, NAN, and Qdrant.
Now, that's my lane. Rapid prototyping, business logic. I love NAN. For anyone who hasn't used it, it's kind of like Zapier, but you can host it entirely yourself.
Very powerful. But on the right side, you have the code or custom route, Python, Ollama, and the OpenAI SDK.
Wait, hold on a second. OpenAI SDK. I thought the entire point of this document was to not use OpenAI.
Right. This is a really brilliant technical detail. The open source community realized that over the last few years, literally everyone was already writing their application code for OpenAI. So tools like Ollama were specifically built to be OpenAI compatible.
What does that actually mean in practice when you're coding?
It means you can take a script that was written to talk to GPT-4 in the cloud. And with exactly 1 line of code change, literally just changing the base URL variable to your local host address, you can trick the code into talking to your local Llama model instead.
So you get all the convenience of the standard coding libraries that everyone already knows, but with the total privacy of a local model.
Exactly. You were just spoofing the API.
That is extremely clever. Well, let's see what this actually builds. The blueprint gives us 2 practical use cases. Page 10 is Blueprint A, Privacy First Financial Analyzer.
This is your classic, please do not upload this to the cloud scenario. You have your PDF bank statements. You want to know where your money is going.
The flow on the page is input PDF statements, then process text extraction, then the orchestrator, which is N8AN, here runs an LLM. It specifically calls out Quinn38B via Ollama.
And why Quinn38B? Because it's a mid-size model. It's smart enough to handle complex financial categorization, but it's small enough to run on a high-end consumer GPU without choking your system.
And there's this big stamp on the slide, local execution, no cloud upload.
That is the ultimate peace of mind feature. Look, I wouldn't upload my credit card statements to a public chatbot. I just wouldn't do it. But if it's running locally on my Mac Studio, entirely air-gapped, sure, why not?
Let's look at the results it gets on page 11. Generated insights. It created this really clean data table. It flagged digital services as a high trend and travel as seasonal.
It even generated an action items list, like cancel unused subscriptions, Heroku, Slack, review travel booking patterns.
And the really eye-catching metric at the bottom, projected savings, $2,253 per year.
That is highly tangible value. You just saved over $2,000.
And just to reiterate the privacy check printed at the bottom, processed local bytes sent to cloud.
That is the true promise of local AI realized right there. Very high utility with zero privacy compromise.
Let's look at Blueprint B on page 12, the email guard. This is described here as a logic gate.
This solves the volume problem. We all just drown in email. You can't read them all, but you really can't afford to miss the important ones.
The flow for this one is fetch unread emails, the LLM analyzes and classifies them, and then it splits into 3 distinct branches.
Branch 1 is marketing and spam. Action, archive. Just get it out of my face. Branch 2 is security risk. Action, flag HTML or malicious links.
And branch 3 is opportunity. Action, draft, reply, and alert human. So high volume screening with zero privacy compromise. Because again, having an AI read literally every single one of your personal or business emails requires an immense level of trust.
Exactly. If you did this in the cloud, you are basically ceasing a massive tech company on every single email you receive. Doing it locally is the only way that keeps it truly private.
Page 13 actually shows us the implementation details for this email guard. This one uses the Python path instead of any N.
Yeah, we're looking at standard Python 3.11 code here. And exactly like we discussed, the SDK is OpenAI agents, but you can see the base URL is pointed directly to localhost.
The logic snippet is actually pretty readable, even for me. It says, if classification equals human opportunity, agent.generate reply. And then elif classification equals security risk, flag content.
It's just basic logic statements. It's not black magic. And the output console example on the slide shows result, email flagged, automated job listing with embedded HTML potential risk.
It's really amazing to see it written out in code. It makes it feel so achievable. You look at it and realize, oh, I could actually write that.
That's the most empowering part of this whole blueprint. Once you strip away the magic black box mystique, it's literally just a script running on your computer.
To help us actually build this, page 14 gives us the Builder's Toolbelt. It's a rapid-fire summary of all the icons and logos we've been seeing.
Right, so if you are going shopping this weekend to build out this stack, here is your shopping list. For infrastructure, Docker and Ollama.
Databases. Qgent for vector memory, which gives the AI long-term memory, and PostgreSQL for your structured data.
Orchestration. N if you like the drag-and-drop visual style, or LangGraph if you prefer to write code.
Evaluation, LM Stats Arena, so you know you have the best model.
And for resources, it mentions the HubSpot Cloud Cowork stack. And for SDKs, the OpenAI Agents SDK and the Google ADK.
Screenshot that page if you're listening. That is your ultimate starter pack.
And that brings us to the final page, page 15, the manifesto. The future is private, local, and agentic.
It's a checklist, and literally everything is checked off. Let's just run down it.
First box, quality. Parity with closed source reached. Check.
Second box,
Right.
Privacy. 100% data sovereignty via local hosting. Check.
Cost. Zero marginal cost for inference. Check.
That zero marginal cost concept, that is the real game changer for me.
It changes your incentives completely. Think about it. If you are paying per token, you hesitate to ask follow-up questions. You want to get it right the first time. If it's free, you can have the AI loop over a complex problem 50 times until it gets it perfect. You can actually afford to be computationally inefficient to get higher quality.
Innovation. Global contribution model. Check.
And then there's the final call to action in big, bold letters at the bottom. Download Ollama, pull a model, build the stack.
It's a directive. We have the tools. The barriers are completely gone.
I think the synthesis here is crystal clear. We have spent the last few years renting intelligence. We were totally amazed that the machine could even talk to us. But now, the novelty of the chat interface is over. The utility of the true agent is beginning. And the fact that we can run these agents on our own private machines fundamentally changes the economy of AI.
It democratizes it in a way that just having a ChatGPT subscription account never did.
Exactly. When you pay a subscription, you are just a user. When you run the stack, you are an owner.
And that is a very powerful place to be.
I want to leave you with a thought. We've established today that the moat is gone. The tools to do this are free. You can have a genius-level intern running on your desktop 24/7. So the question is no longer, can I build this? The question is, what